Good morning, students. In the last lecture, we have discussed about Gauss theorem. Now, here we are going to discuss about the application of Gauss theorem. About the application of Gauss theorem. What are the application of Gauss theorem? We are going to just discuss with these points. What are the application of Gauss theorem? The very first application of Gauss theorem is that electric field intensity due to an infinitely long straight uniformly charged wire or line. We are just going to find out that electric field intensity due to an infinitely long straight uniformly charged wire or line. Now here what we are going to do, let us consider an infinite and very thin straight uniformly charged wire having linear charge density lambda. What we are considering? We are considering a infinite long very thin straight wire which is uniformly charged having linear charge density lambda. It is an infinite long straight wire. Now what we are going to do? We are going to let us draw an imaginary cylinder, of radius small r and length small l. To find out that electric field intensity, we have to assume a particular cylindrical surface called Gaussian surface around it, which is of small r radius and length small l. It is an imaginary cylinder, that is why I'm just making it like dotted form. This can be taken out. The length of this can be written like small l as we have considered, and the radius of it we have considered like small r. So what is next? Next is that we have to take a small area on it. It behaves like a Gaussian surface and we have to take a small area on it called ds area. The electric field is working outward as usual. So what would happen? The total number of electric field lines can be given like the small flux d phi is written like what? E dot ds. It can be written like E ds cos 0 degree. This can be written like what? E ds. D phi E can be written like what? Small flux can be given like E ds, because cos 0 is equal to 1 as we know that. This one is question number 1. But total flux through Gaussian surface is given as phi E is equal to we are talking about a surface, so we have to take a surface or line. We are talking about a line actually. We are talking about a wire, so we are taking a line integral of d phi E. So here we are putting the value from equation number 1 and we are getting this particular. But what is the curved surface area of a cylinder? We know that the curved surface area of cylinder can be written like 2 pi RL. 2 pi RL. This one is question number 2. But we know that, or we have, what we are having? We are having phi E is equal to 1 upon epsilon naught times of the total charge. That is what? By Gauss theorem. By Gauss theorem we have this. So by equating equation 2 and 3 we get, by equating equation 2 and 3 we get what we are getting here, that E dot 2 pi RL would be equal to 1 upon epsilon naught times of the total charge Q. This can be written like what? E is equal to Q upon 2 pi RL epsilon naught. But we also have, what we have? We have lambda is equal to Q by L. We are putting here. Then this implies that E is equal to lambda upon 2 pi R epsilon naught. This is your result. This is the electric field intensity due to an infinitely long straight uniformly charged wire. This is your proof.